Over the years, I've always tried to break new ground in vacuum technology. Now with this powerful digital motor, a new era begins. Dyson has reinvented the cord-free vacuum. Definitely not a little portable. This is now your big machine to deep clean right through the home. So powerful, in fact, we've stopped developing corded vacuums.
So we've developed a whole new motor, and that took hundreds of millions of pounds and hundreds of engineers and 5 years to develop. We need to power the motor, so we developed a brand new battery pack. So we've adjusted the chemistry in the cells, we've increased the size of the cells, we've put on onboard diagnostics for blockage detect and filter wash reminder, and obviously battery power levels. So we're getting more power out of it to power our new motor, we're getting more runtime out of it, but it's lighter than the V8 battery pack. We've then rotated the bin assembly, and one of the main reasons behind that was because we recognise that there's a much more there's a growing awareness of indoor air pollution, and you'll have heard of that, heard about that with our environmental guys. So we understood from feedback that customers were preferring to empty their bin straight into a bag, and to take that bag and get the bag out of the home at the end of the clean, so that rather than dispose of it in a dustbin, the debris was still in the home, okay? And so that's where this format really lends itself to, so you can insert it into a bag, empty the bin, and then get the debris out. But what that did was that threw up a number of challenges. It meant that we had to rotate the Cyclone assembly. The Cyclone assembly became a key structural component, so it was now load-bearing, whereas historically it hadn't been. And also it meant that the debris in the bin could travel up and down. And we don't want to do that. We want to control where the debris sits, so we developed this flexible skirt as well, so that the debris can flow past it and sit in the base of the bin, but equally not fall back up towards the top of the Cyclone. We also developed a new combined pre and post filter, and that's what really wraps itself around the V10 motor. And again, that's what promotes this whole straight flow air path. And so the straight flow air path gave us about a 20% airflow saving based on V8. So we've got more suction, we've got more runtime, we've got a bigger bin, we've got a lighter, more powerful motor, we've got a lighter, more powerful battery pack with diagnostics, and we've not compromised the weight distribution and the versatility. So that's why we believe we hit the 4 key design criteria.
So we have last question from
So these are all your challenges, right?
That and, yeah, as I said, how long do you really have?
Okay. And the second question I would like to ask is, just as if Wenky just said, Dyson's vacuum cleaner, the price normally is higher than the other brands' vacuum cleaner, but it really that there are still lots of customers willing to pay more to buy Dyson vacuum cleaner.
Sure.
So what's the reason? Just because of they think that they are more handsome or more proud of using the Dyson because they think they are trendy guy, or?
Well, I can't read their mind for them, but what we hope is that the understanding of the technology, and that we're a technology company, we lead on developing what we believe to be the kind of the best, most relevant technology at the time. And so when it comes to our vacuum cleaners, as I say, that all starts with the motor. And so when you're investing in the Dyson product, you're investing in the development that we've put in to producing a vacuum cleaner that has what we hoped to be the superior performance, and also the kind of performance, as we were explaining, that passes that no loss of suction test for the lifetime of the product. So when you're investing in that, I hope to think that people understand what they're investing in, and it's really the designing and the engineering and the technology that goes into creating not just a vacuum cleaner, but a system of technologies that all work together to give you that high level of performance. And really doing events like this, and then also having our Dyson stores and having our demo stores, and really trying to narrow that gap between the customer and the product itself, and getting people to come in and learn more about it and touch it and feel it. before they choose to make that investment. That's really, really important for us, and owning that conversation is really important for us, and that's why we've been expanding our footprint with our stores and our demos as much as we've been able to.
Why do you guys call it a digital motor? Like, why do you specifically call it a digital motor?
Because it's digital.
What's the, that's
because fundamentally because of the switching. Okay, so first of all, it's a brushless motor, so there's no touching parts. So you know, with a conventional AC motor, we have a carbon brush that has to connect with the rotating part to complete the electric circuit. That doesn't have that. What it has is incredibly powerful rare earth magnets, and that's what allows us to achieve incredibly high speeds. But what we do is we integrate our own electronics. So we develop all of this ourselves. We own all the proprietary ownership of the algorithms and the software that go into it. So actually, the digital element is really about the switching and about the detail that goes into the electronic and the software design to control the position of the rotor. I think it's up to 3,000 times a second. We will constantly check that the position of the motor is exactly the way that we want it, is exactly where we want it to be, and if it's not, then we'll make a digital correction to change that, because we want to maximize the performance. The other benefit that we have with our integrated electronics are things like we have a pressure sensor on here right now, so you may have heard of this, so tell me if I'm repeating something you've already heard, but for example, I could take this to the top of a mountain, any mountain, pick a mountain in India, and then down onto kind of sea level, and it would be able to tell the difference, but it's even more sensitive than that. It could tell the difference between sitting on this desk and sitting on the floor here. In fact, it's even more sensitive than that. It can probably tell the difference between about here and here. And that's important, because what it means is that if you live in Amsterdam on a canal at sea level, or if you live in Nepal somewhere, or wherever it would be high, then the motor is digitally adjusting itself to the atmospheric conditions that it's in, so that you're always getting maximum performance wherever you've bought the machine.
Does that happen intuitively, or does it will it differ for market to market? Like, will you ship a different version in market?
It's all automatic.
It's automatic.
Yeah.
So there is like 10-15% performance jump in motor speed over the previous one. It's 125,000 RPM now.
Absolutely.
Is it just the ceramic shaft that is contributing to this jump, or the entire assembly?
It's the full package. So we began developing this 5 years ago, and we, as I was saying before, we developed the product 3 years ago, so we really the lead on the motor technology. So yes, we have a ceramic shaft because of the speeds that we're rotating at. So the ceramic shaft allows us to rotate at that speed. It doesn't give us the speed, if that makes sense. So it's more it's stronger and stiffer than steel, and it's lighter. So that's the benefit of the ceramic shaft. It allows us to rotate at that speed. But it's the electronics and it's the switching that I was explaining, and it's the really powerful magnets that we place in there, and then the impeller design. We've got what we call a diagonal vein impeller design that was designed in conjunction with the University of Cambridge. So we do research elements within the design of the motor as well with universities. And so it's the combination of the new impeller design, the magnet design, the electronic and the switching and the algorithm design, as well as the mechanics of the motor, the packaging of it, because we're now rotating at 125,000 RPM. It's kind of mind-blowing that every minute it's 125,000 times, right? So we use other materials other than the ceramics. We use space-age materials. So there's a phenolic glass that we use as part of this main, what we call the can, but the main structural component. Now, you really only find that on satellites because its weight to strength ratio is incredibly optimized. So not only are we rotating at a much higher speed, not only are we generating even more airflow, but it's lighter than its predecessor motor as well. And so what we find is that there are other digital motors in the market, but the closest digital motor that we find at the moment is about 3 generations behind where we are now. So we believe we're at least 3 generations ahead of any other digital motor that's out there.
When you say you get longer runtime from this, you're comparing to the V8, right?
Yes.
Do you get longer runtime at the highest speeds?
No.
Okay. So what's the comparison?
So we what we have is we have a max mode, and so I think that there's still an understanding with the product that we feel that some of our customers need to have. So what we prefer to assign or use the max mode for are for those really ingrained situations. So for example, your child's come in from playing football or soccer, and there's that dried out mud in the rug or the soft furnishing or the carpet, and you really need that maximum level of performance to get that really deep ingrained dirt out of the carpet or the rug. And so that's where we really feel that mode comes into play, whereas actually, because on the V10 we've now got 3 modes, so in the mid mode you're going to exponentially increase your runtime for the cleaning task and still achieve a really great balance between suction and runtime. And so I think there's a lot of learning still to be done globally with how to best get the best out of the product. And I think what's also important when we talk about runtime is if we go back and look at V8, we received some great feedback. So V8 was our most successful clog-free cleaner ever. We sold faster than anything else. That was really good. But what was actually really important was that people fed back to us that about 50 to 75%, depending on the country, used V8 for all of their vacuum cleaning and no longer went to the corded vacuum cleaner that was still in the cupboard. And that surprised quite a lot of people, where they said, well, this kind of meets my needs now. I don't need hours and hours of runtime, because actually I have a very busy lifestyle, and I don't set aside 3-4 hours a week to do all of my deep clean. I do 20 minutes here or half an hour there. And actually V8 played very well into that space. So we've increased the runtime on a V8 up to 60 minutes, but depending clearly on what mode you're in and what accessory tool that you're using, so it's a range. And so we believe that, based on the feedback that we've been receiving, that actually people have still got a bit of a psychological barrier to go through with cord-free technology, and actually, well, how much runtime do you really need? Do you want hours? And are you going to vacuum clean for hours and hours?
No, you're not.
Sure. So it's a really interesting sort of discussion that we're having with our users or potential users at the moment, because I don't think people all actually think they know what they want.
There is like a lot of emphasis around acoustics. We have been seeing this throughout the day. How is sound dampening happening over here? Because it's considerably quieter than especially at the RPM that we are talking about.
Yes. So I think you missed the answer to the question just before you came in. So we do a lot of noise management, and as you've seen with our facilities here, and so the facilities here, we've got sort of 3 to 4 times as much in the UK, and similarly over in Malaysia where I'm based. And when it comes to V10, we try to manage the two things. We try to manage the airflow, because the airflow it generates noise, and clearly as you know, the motor generates noise. So it's these two things that we're trying to manage. And so we, at every stage through the product, we try to control how many twists and turns the air has. Every time you pass air around a corner or over a surface, it generates noise. And so with the inline format of V10, that plays very well to that. Equally, we want to try and rotate the air by 180 degrees, because we're going to remove energy from the air, and that's going to naturally reduce the noise. So that's something that our post filter does. So as the air's entering the filter, it's actually forced round and then out of the exhaust holes, and that removes a lot of noise. And then equally, in our motor bucket, so it's probably easier to show it on this. In our motor bucket, we have noise deadening materials. In the filter, there's noise deadening materials. So it's all about starting at that maximum raw noise, and how many times can we just bring it down to an acceptable point, so that you find that balance between suction and noise.
Is that rubber?
Which?
The material here?
Yes, it's an expanded polyurethane foam.
Okay.
Yeah.
Are these two different sizes that will be available?
They are indeed, yeah. So what we have is this one here, and we have this one here. So what I crudely call big bin, small bin, for obvious reasons, but they also have different filter designs as well. And so this is designed for the bigger markets with lots of carpet area, big square footage houses, where suction and volume is a real kind of focus. and this is designed for houses with maybe hard floors, so not so much ingrained dirt because there's less carpet, but equally there's lots of soft furnishings, and filtration is still incredibly important, which I'll talk about in a second. And so what we can do is we balance the suction and the noise. So this product here has 130 air watts and around about the 80 dB noise mark, whereas this product has 151 air watts and it's about 84 dB, again all depending on the mode. Okay, and so they're the two options that we have.
As in, is there a difference in any performance battery life between the two, or is it just the capacity?
Yes, so you can also see that the packs are actually the same. So we achieve the 60-minute runtime with both models.
All right.
So, but India is going to be getting the
smaller one only. Okay, all right.
Because generally in Asia, because I think they prefer lighter machine because it's also mostly women who use it. So.
Is there an ideal value for this decibel? I mean, Dom said that we would prefer 0, but still.
It really depends on what you're looking for as a customer, because we all live in different houses and we live within different proximities to your neighbour, or who are you going to be disturbing. We clean at different times, so it's the classic vacuum cleaner conundrum. You know, how much dust do you vacuum up every week? Well, it's different from you and it's different from me, so how big do I make the bin? You know, there's 1,000 questions that actually, because it's so unique to the person or to the home or to the floor surface, that it's quite tricky to just nail down that perfect point. But what you'll generally find is when you get down into the 60s, the 50s, the 40s, that's where your kind of aircon is sitting and that kind of thing. So I'd love to get down there, but I'm not going to make any promises in this room today, otherwise I'll be in trouble.
Why don't you guys do wet cleaning with the vacuum cleaner?
At this point in time, we're purely focused on the dry cleaning because of the history that the journey that we've come on so far. But all I would say is that we're looking at everything. So we've got £7 million a week investing in R&D. We've got nearly 50% of all the Dyson employees are engineers or scientists. We've got 200 live projects going on right now across the research and development facilities, and we're investing £2.5 billion in future technology. So you can rest easy knowing that we're looking at everything.
So how often do you see a need to refresh a device like this? How often do you think that, okay, we have reached that point in innovation in a year and a half, 2 years, that we need to bring it out in a new product? Because these days we see a lot of devices that are launched every year, every 2 years. So is that something that you'd follow on this, or is it purely based on when you need to?
Well, there's two ways to answer that. So we're constantly developing technology, and we lead on the technology, and that's the most important point to understand. So to veer away from vacuums for just a second, the supersonic hairdryer is a perfect example of that. That did not start on day one as a hairdryer. It began as a piece of technology, and then it was identified that it could be applied to become a hairdryer. And so, as I was saying earlier, with V10, it's no different. So we started to develop the motor 5 years ago, but we were developing the product only 3 years ago. So this is 2 years ahead. So you start with the technology. So when the technology comes to the surface, then we'll begin to build the product around it. And so there's no real way of predicting the cadence of having that next breakthrough technology. And so that, in part, is what will dictate the end game for the product and the kind of cycle output of the product. When it comes to V10, we're very proud to make it clear this is a new category of vacuum cleaner. This isn't an evolutionary product. So the reason that we believe that is, again, back to the 4 principles. We wanted the suction of an upright. We wanted more bin capacity. We wanted longer runtime, but we didn't want to compromise the versatility and the handling. Achieving all 4 of these things is not an evolution. And again, back to the point about V8 and the feedback that we got with V8. It was great feedback, but what that actually meant was that about 25 to 50% of our potential customers are still very faithful to corded vacuum cleaners. So it was great feedback, but we kind of pushed that to the side and go, well, that means that actually there's still this many people that need pulled away from or have that battery anxiety kind of broken. And that's where V10 really comes into play, because we have the suction now, and we have the capacity, and we have the runtime. And so that's what we believe is creating that balance between what was a cord-free product and what was a corded product, and we're getting the best of both, and it's creating a new category. So V10 for us is anything but evolutionary.
We've got about 5 minutes left.
It might sound silly, but I mean, have you done any feasibility on whether this motor can handle the new motor can handle wet cleaning? Not the product, I'm just talking about.
No, it's not a silly question at all, and we will inevitably test for that, because as much as we will advise people not to vacuum up things that we think is undesirable, we know that it's going to happen if it's accidental or perhaps not, for fun perhaps. So we have a load of tests. So we test 24 hours a day, 365 days a year over in Malaysia, and we have hundreds of what we call DTM, so Dyson test methods. So these are tests that we've concocted over the years, and their at last count is just shy of 1,000 of them. I think we're over 1,000 of our own tests that we've come up with. So you have standard industry tests that we have to comply to, but these are tests that we've concocted, and one of them are a suite of water tests. So we have salt water spray tests, we have water ingress tests, because we need to make sure that if somebody vacuums up some liquid, even if they didn't mean to, that the product's not going to become unsafe. Okay, so yeah, we test with a lot of water, and it can have some interesting results.
So yeah, go ahead. So I was there at the India launch when you did a press preview for India, and how you explained the dynamics of dust. Now that's a very, very Asia, very India-specific question. None of the other societies we know have the approach to cleaning that we do. The sweeping, the mopping.
Sure, yeah.
So the way you explained the dynamics of dust and how a vacuum is better, could you also put that on record?
Sure. So were you there when I was presenting?
Yes.
Oh, okay, great. So we know that of the traditional cleaning methods, and we're at the moment we're doing some dust studies in India, because obviously we want to learn a lot more about that market. But the common misunderstanding is that that level of cleaning actually creates particles that become airborne. And so even although the floor may look superficially clean, actually what you've done through the sweeping, which is a dry process, is you've gathered up the majority of the larger, more obvious dusts, but actually you've projected into the air the smaller, more harmful, so the mold spores, the dust mite feces, even the cigarette smoke and the pollen, all these things that trigger our allergies, and they're the ones that we're most worried about. They're the really small ones. What's more is after the sweeping, when we come along with a wet mop, anything that's been airborne and has resettled itself on the ground, a percentage of that will settle itself on the ground, and what we do is then make that into a paste, and that paste is then spread across your floor. It looks clean, but it's not clean. And then eventually over time, whatever's left that's airborne will settle, and so that's where, because of the design of the Dyson cord-free cleaners, so specifically with the V10, we have the Cyclone technology. So we've got the motor technology, which is driving huge amounts of suction power. That is powering our Cyclone, so we are rotating at incredible speeds. So inside this cone, the air is travelling at about 140 miles an hour. It's exhibiting forces in the tens of thousands of gravitational acceleration. So for example, if a Formula 1 car driver is going around a bend, they may exert maybe 1 or 2 G, Any Air Force pilots, fighter pilots, it could be up to 6 or 7. We would all pass out, we can't handle that. The air inside that Cyclone is experiencing 79,000. And that's the difference. So all of those dust particles that can become airborne, that you can't see, that you could be breathing in, that could be triggering your allergies, they're all captured in here because of the extreme forces that they experience, both in the Cyclone, and anything that's even smaller than that is then what's caught in our post filter. What we relentlessly test for is our sealing capability. So in our production lines, we test every single seal as the product is being put together. What we also then do is we have environmental chambers that we'll put the machines into, and we'll raise and lower the temperature between 40 degrees and minus 20 degrees to mimic the profile of the worst case shipping to Canada, for example, which can take 7 weeks, 8 weeks. What that does is it exercises the seals. and it stresses the seals. And then we go back and we retest all of those seals to make sure that they still seal. So what that means in total is we have very, very high level filtration performance in the Dyson vacuum cleaner. Ultimately, it means what goes in stays in.